Alrighty, guys. Looks like our exam is on next Monday, the 12th. So let's do a little bit of a review. Pretty much, if you do the first two tests in MindTap, you're going to be well prepared. Questions will be drawn directly from there. And when I say look at them, go ahead and do them, but then review them. They are open, are they not? Doubly sure. Okay, so the first one's still open, the second one's still open. They should be set to unlimited tries. If you don't do a great job the first time, you feel like doing a good job in the second. So review the exams, the tests. Look over everything you've submitted in a daily assignment, right? Then, look over the daily notes. And so specifically, there's going to be some stuff on flowcharting. What are the different shapes? What do they mean? So for example, we've seen a decision block. We've seen process block. We've seen predefined process. We've seen data. Terminators. That's really about all we've seen. So what does an if look like? What does an if with an else look like? And what does a while look like? That kind of stuff. If I give you simple flowchart, do pseudocode from it. If I give you a simple pseudocode, do a flowchart from it. Also, no data types. We've talked about three main data types. Ints, etc. What is the difference between a syntax error and a logic error? We did some stuff with binary at the beginning of the semester. Example, what is in decimal? What is, in hex? That kind of thing. Following the rules of precedence, which is higher precedence, multiplication or addition. That multiplication has higher precedence than addition. So if I say A is equal to 3 plus 4 times 5, you'd be able to figure that out, because which part do you do first? The multiplication, then the addition. be able to write Python code that does something like this. Ask the user for their age, accept input, convert the result to a float, that kind of thing. Or ask the user for their name, then display hello followed by their name. Stuff like that. Know what a division does, what floor division does, and modulus. All right, that ought to be enough. I'll try not to make it too hard. I don't want to make it, so that you have to overly stress about it, so that it doesn't take you more than an hour to do. If we have to hang out extra time here to finish exams, if you don't have to run off, we have some extra time that we can be in the room. I'm not going to post it, but you can go and review the first 5 minutes of the video and take notes from it. Yeah, why not post it? I don't see why not. I will post it. All right, so the last thing we saw was how to do a priming read. A priming read is when you ask for some data or you get some data out and then you go into the loop. And then while you're in the loop, you keep asking for more data. This kind of thing. What is the test score or -1 to quit? They type in a number, whatever. So we would print that out, and then we would input their score. And while score is not equal to -1, add score to total, which we could rewrite as set total equal to total plus score, right? And then ask them for their score again. Print what is the test score or -1 to quit. And then input the score again. That's one way to do a data entry loop. The first read is known as a priming read because without it you can't get into the while loop to begin with. There are other ways to do it. I'll show you 2 ways. One takes advantage of what's known as a break statement. The other one just goes ahead and follows, strict. Doesn't introduce anything that we don't already see in this one. And the idea behind that is you set score equal to a value that will let it go into the loop, and then you ask for the score. Input what is the test score or -1 to quit, and you get that score. Actually, that was a print statement. You get that score, input score, and then you check. If score is not equal to -1, then you add it to the total. Set total equal to total plus score. And I guess since I'm doing pseudocode, I should be putting my end whiles there. Not that that's a Python command, but that is what they do at pseudocode to mark the end of a while loop. Okay, so these 2 things are logically the exact same. They perform the same functions. The difference is that the one with the priming read, the input and the output is done in 2 places in the code. You have to do it before the loop, and then you do it again in the loop. Whereas with this second method, you only get your input in one place inside the loop, but the complication is that you have to have an if statement inside your while loop in order to get that to work. I prefer this second style myself. I'd rather only do the input and output in one place. Excuse me, I'd rather only do the input in one place. They both work. We'll come back to this idea because we're going to be doing things where you ask for input and you process it a lot. I'll go ahead and show you the third way. It takes advantage of something called the while true, which you just repeat forever, except we're going to throw in a break statement that bails you out of it. Print what is the test score, or -1 to quit. Input score. If score is equal to -1, then break. End if, end while. And what break does is it causes it to bail out of the while loop. So if they ever do type in a -1, it bails out. That's my favorite kind of data entry loop, but the books don't show it, and it's harder to flowchart. So typically, the books show this method with the priming read. So this is an example of input without a priming read. This is an example of input with a priming read. And this is without a priming read using a break. 3 ways of doing it. And I could flowchart it for you, but we'll hit that topic again. Here they show in several slides in a row how to not do it, not how to flowchart it, and then how to do it. So this is a flowchart for priming read. You do your declarations, you get your input. Is the input valid, or while the input is valid? Yeah, do something, print out the answer, and then get the input again. And so you can see that this input step is repeated twice. It was before the while, and then it's inside the while loop. Understanding the reason for structured programming. Pretty much everything we do is structured programming. It's hard to find a language that doesn't force structured programming anymore. But use structured programming for clarity. Unstructured programs are confusing. Professionalism, other programmers expect it. Efficiency, most languages support it. Maintenance, other programmers find it easy to read. And modularity, it's easy broken down into modules. Structured programming is sometimes called go-to list programming. And that's because some really old languages, and Assembler and the old version of BASIC, supported something called the go-to statement, which made code hard to read. And I already showed you an illustration of spaghetti code, but I didn't come up with a good one. But it's something like this, you know. Input A. If A is equal to 0, go to done. And then, you know, you would have maybe some line numbers out here to the side, you know, like this. Print, give me a number. And instead of saying go to done, I'm going to go to a different line number here. Okay. 40 total equals total plus A. 50 go to 10. 100 print total. Now there's a problem with this code, which is that I never declared total. So I'm going to declare total up here. This is what it used to look like when you did programming. You fired up your Apple II or your Commodore 64, or you logged into a computer with one of those scrolling typewriter keyboard combinations and did some basic programming. So there we go. Except if we were doing real basic, these things would have the word let in front of them, just like they have set in our pseudocode. But anyways, you get the idea. There are go-to statements. There's no while loop, but it's the same as a while loop, right? Because if you follow the logic, give me a number, they type in something. If they type in a 0, we skip everything and go to the total. Otherwise, we add it to the total and we loop again. So this code is the exact same thing as doing this. Total is equal to 0. Well, it's not really the exact same as anything, but score is equal to something that won't cause it to fail, while score is not equal to 0. Print, give me a number. Input A. Actually, I guess that should be A is equal to 1. Input A. If A. I should have just done a priming read. If A is equal to not equal to 0, then go ahead and add it to the total. And then at the end of our if, then at the end of our while, and then print the total. Those do the exact same thing. One is a structured program, one is not. The second one is structured. Some people, when they see the first one, their eyes light up. Whoa, I understand that better than a while loop. Yeah, for simple little loops like this, that's true. But the fact that you can have go-to statements that run to any other place in the code means that you could write code that could not be duplicated with structured programming at all. And then if you go in and you try to modify it, it becomes much more difficult to follow. That's the spaghetti code that I talked about. And you can draw a flowchart that you could implement with go-to statements, but that you could not implement with structured code. So does that mean that the go-to version of it's better than structured code? No, the structured code, structures like the while loop were made for a reason. They're made so that the code is easy to understand, easy to diagnose, easy to figure out what it's doing. The same thing happens every time it goes into it. You could figure out real easily how it works just by looking at the structure of it. You get ideas of the structure of it based on the tabs. So no modern language supports a go-to statement in that effect anymore. Or if they do, well, C++ does, but that's because C++ goes all the way back to C, which came from 1970. So this is structured programming. You could do module calls using go-to statements, but they don't look the same and they're a lot more trouble to set up. Maybe the language has something called GoSub, which is the same thing as a module call, if you're talking about BASIC. Anyways, I just want you to get the idea. If you ever see code that has go-to statements, that's how it works. Sometimes they have names rather than numbers. If you were going to rewrite this so that it had names rather than numbers, it actually looks a little bit better. Like this. Give it a name, top. All right, so now we're going to read it. Total is equal to 0. And then at the top of the code, give me a number, input it. If the number is equal to 0, go to done. So that's the key to stop. That's our sentinel value. Know what sentinel value means, even though I didn't mention it in our notes. I've said it several times. And then, so if it equals 0, go to done. If that's not true, we add it to the total and we go back to top. And again, that makes more sense, to some beginning programmers. Looks better to them than writing it as a loop. And all I can say is that for complicated programs, using go-to statements makes things impossible to diagnose. There's a reason why everything is written using structured programming languages like Java or C++ now. So I'll just put a comment. And could you write a language that had both while loops and goto statements and stuff like that? Yeah, but what if you had something that looked like this? We're just going to pretend here. But I'm going to put a label here. And then what if we had a goto right down here at the bottom, goto test, right? So when it ran the whole way through and then it hit goto test and it jumped back into the loop? How does that work? It doesn't really. So there's a reason that the structured programming languages don't have goto statements or don't support them for the most part. Recognizing structure. This is what's known as a nested structure. Which one of these structures is a loop? Is D a loop or is E a loop? D is the loop. How do you know it? Because a line comes back to the D. Nothing ever comes back to the E. So E is not a loop. So broadly speaking, over here, this looks like this. If D, and then tab over. While E, if that's true, do F. End while, end if. That's this thing in code there. You can tell which part's the while loop. No, I've got that backwards. I did it exactly wrong. What did we say? The while loop was based on the D and not the E. My mistake. I would fail my exam. All right, let's fix that. There we go. Now, whatever F is, it had better change this state, or else it's an infinite loop. Right, because if you did while x is less than 0 and nothing ever changed x, then if it went into the loop, it would just keep going because x would never stop being less than 0. Let's look at this other one. That's just an if statement. Do A, and then if B, do C. Like that. Oh boy. All right, this one's horribly structured. And then notice, this program segment is not structured. Why is that? Because our rules are that if it's an if statement, they need to join back up in a circle before they go on anywhere. This does not join back up together in a circle before it goes to there. This one does, you know, once they go over here and do that. But this is not structured. You could not write this with Python code. You could kind of hack it so that it, you know, add different if statements and stuff like that to get it to work. But it's not structured programming, as is. Now this one's bad because there's no yes block. Why would you have an if statement and it only does something if it's no? There's only one line coming from it. If you have a diamond, there always has to be two lines coming from it, a no or a yes, or a true or a false. So this one's good. But then we have this one. This is crazy. I don't even know what they're trying to teach us there because that's horrible. I kind of get it, but since this one doesn't have a yes block going off to the side, we couldn't figure it out.
I think it's doing a progression thing.
Yeah. And here we go. If H is true, we come over here and we do I. And if I is true, we do K. If it's not true, we do J. If it's not true to begin with, we also do J. That's pretty weird. Some of these things you could rewrite using what's known as or and logic. That'd be a more efficient of writing this way of writing this thing. But let's do a nested loop that kind of looks like this, that has three possible outcomes. Not on the loop, I'm sorry, nested if statements that has three possible outcomes. This really, if we inspect it closely, only has two possible outcomes, but we want three possible outcomes. And I'm going to draw the flowchart for it really, really quickly. And I'm not going to ask you all to do it. Wouldn't be anything wrong with you doing it. All right, what this program is going to do is just ask for the temperature, and then it's going to print whether the water is boiling, freezing, or liquid. So I would always start flowchart with a terminator. Then I'm going to ask for the temperature, input the temperature of the water. Then underneath that, I'm going to do an if statement based on it. And we want three outcomes: boiling, liquid, or frozen. So we're going to assume that we're doing Fahrenheit, at which point the boiling is 212 degrees. So, if boiling, if temperature is greater than 212, then print boiling, output boiling. But if that's not true, we're going to have another if statement. If the temperature is less than 0, that means it's freezing. So in that case, we're going to output freezing. And in a minute, I'll move the blocks around so that it looks a little bit better. Can I type? Come on. All right. Now, this is a horrible flowchart at this point because I have dead ends, but it's because I'm not done with it. And if the temperature is not less than 0, then we're going to print liquid. So those are our three choices. Then things need to start joining back up, because if statements always need to join back up. But that doesn't count for this one, which also needs to hook back up, right? Because we output boiling over here. And so that needs to come over here to another circle, as well as this one. And then we're done. So I'll put a terminator at the bottom. Trying to kind of squish it all horizontally. Or vertically, excuse me. Alrighty. Come back. Increase the font size. Make it a little bit more readable. Okay, so there's our flowchart. It's got a nested if. It's actually nested on the else side, right? Because this is the if side. If the temperature is greater than 212, output boiling. If not, the else says if temperature is less than 0. If that's true, you output freezing. If not, come over here and output liquid. So those are our three mutually exclusive results. Why? Because according to our logic, something can't be both freezing and boiling at the same time. And then since we have an if here, they have to hook back up together. And since we have an if here, they have to hook back up together like that. If it was a while, they don't hook back up together. Instead, the line comes back up to the diamond. We don't have any loops in this one. So let's code this one in code. Let's go ahead and put this one in idle. All right, so name, date, whatever. Then start, print, what is the temperature of the water? Why am I specifying water? Well, other chemicals have different boiling points. Also, the boiling point and the freezing point depend upon the air pressure. So, at higher altitudes, water boils at a lower temperature. But we're going to pretend that this is all at sea level. So then we need to input the temperature. Temp is equal to input. I also should have specified the units, right? This is all in Fahrenheit, or else we would have to change these places. So the first thing after the input temperature is the if statement. If the temperature is greater than 212, print boiling. And do we have an else clause? Yeah, we do. If the no line just dropped and went to the circle without doing anything, there'd be no else. But that's not the case here, because the no line is going to some more code. So we do need an else. Else, colon. What's after our else? It's another if statement. And you remember a while back I said that students always wish there was an else block that they could put in their flowcharts. If you wanted to, you could put the word else after the no, or something like that. But that's not book perfect flowcharting. Alrighty, so we are here. So if the temperature is less than 0, the yes side of that is to output freezing, so print freezing. And does this one have an else clause? Does this if block here go to an else? Yeah, it does, because it doesn't just drop straight to a circle. It's got some code that executes on the no side as well. So else, print, liquid. If we wanted to do it in pseudocode, we would put end if statements. Since we're doing programming in Python, we don't have to, but I'm going to put them there anyways. And then stop. I guess we could print a done message just to show that we were done, even though this logic didn't show it. Alright, if I did it right, we should have a working little program, but I may have syntax errors. March 7.py. Alright, what's the temperature of the water? It's 100 degrees. and boom, it blows up. What is this an example of? Is this a syntax error? No, it's not a syntax error because I didn't make any typos, but I did forget to do something. The problem is around here. What did I forget to do? It's not the indentation.
You gotta convert temperature.
Exactly. Temperature is a string at this point, and as I've mentioned several times, I didn't forgot myself. An input in a flowchart or in pseudocode turns into 3 statements in our Python. When you print it out, you call input, and then you convert it. So temp is equal to float temp. Now to work. I hope. All right, so I need to test it 3 times. I need to make sure that it'll do liquid and freezing and boiling. So I'm going to run it 3 times. If it's 0 degrees, is it supposed to be liquid? No, that looks like it might be a bug. Oh. Well, for one thing, I used the wrong boiling point. Anybody really remember the freezing? I meant the wrong freezing point. Everybody really remember the freezing point of water? It's not 0, it's 32. All right, so if I type in 0, it should say it's freezing. If I type in 300, it should say it's boiling. Anywhere between 212 and 32 will be liquid. All right, I think I've used the term magic numbers. Are there any magic numbers in this program? What are magic numbers? They're just literals. Those numbers that are hard-coded into the program that the user doesn't type in, the programmer typed them in. And if you're reading the code, you might not know what they mean. Somebody from Russia who's using Celsius won't know what 212 is. They won't know why that's magically the boiling point, because in Celsius the boiling point is 100. So 212 is a magic number. What's the other magic number in here? 32. And the best cure for magic numbers is to define constants. So I'm going to go up to the top of my code and do boiling equals 212. Freezing is equal to 32. And then I'm going to replace those numbers. The 212 should be boiling, and the 32 should be freezing. So now we have a declaration block up at the top. And so really our start should be moved down underneath the declaration. No, I'm not going to say that. I'm going to leave it where it was. Okay. Hopefully that didn't break my code, and then I'm going to do a walkabout and make sure y'all don't have syntax errors. But what's the advantage of defining these as the constants up at the top? Well, if we decided to write it in metric, we just have to change the numbers in one place. Boiling point in metric is 100. Freezing point in metric is 0. It's easier to remember than our system. On our merry way. So some of these structures look totally weird to me. I'm just going to not bother trying to figure out what they were trying to do here. For example, this one and this one are the same. It's just that they don't show them hooking up together. Guess I should read go back to that page on the textbook and see what this is trying to tell us. But since we have an if statement here, they should hook back up. That's what they're showing there. And then we have a larger if statement here, and they should hook back up, just like our flowchart did. Okay, so yeah, they're just kind of trying to do it modularized, where they're building the complete version. That's why some of these look wrong to my head, and that's what you said, so I should have listened to you more carefully. Alrighty. I like my examples better than theirs. I'm going to stop looking at their examples. So spaghetti code is statements that do not follow the rules of structured logic. It's really hard to write spaghetti code in Python because you don't have go-to statements. So we have our 3 basic structures: the sequence, the selection, and the loop. Sequence are just the process blocks, you know, and input statements and output statements. Selection are your ifs, and your loops are your whiles. You stack them, you know, you put stuff on top of each other, and then you nest them. You know what your priming input is? It's when you read the first input value prior to going into a structured loop. I'm not going to ask you for the 4 advantages of structured techniques. Just remember that it's really amazingly important. Structured techniques let you do clarity, professionalism, efficiency, modularity. Flowcharts can be made structured by untangling logic. That's what they were trying to illustrate on the past few pages. And logical steps can be rewritten to conform to the 3 structures: sequence, selection, and loop. I think I could draw a flowchart that you could never convert to the 3 structures, but you know, that'd be pointless. That would be spaghetti code that was, you know, unrecoverable, and you ought to just sit back down and redesign your code if that was the case. But since we don't have the goto statement, goto is a keyword. If I type goto here, oh, it's not even a keyword in this language. In a lot of languages, it's a keyword, but it doesn't do anything, and it causes a syntax error, just to prevent people who are used to programming in languages from trying to do it. And this one is just treated as an identifier. All right. So although our exam is putatively billed as covering chapters 1 and 2, in class we've done a lot with looping as well. So our exam is going to cover looping, even if the exams online do not have a lot of questions over looping. And so at that point, we were done with chapter 3 already, which means we would be starting chapter 4 before we take the exam over chapters 1 and 2. That doesn't seem like the best of all possible ideas. I think we ought to go back and do some more turtles then. So here's what I want to do with my turtle. I wanted to start from the center and go a little ways, and then go a little ways farther, and a little ways farther, and farther, and farther, and farther, like that. I wanted to draw a spiral. So how am I going to do that? What kind of structure would support this? Is it going to be sequential statements? Yeah, there'll be some sequential statements, right? You have to create the turtle and you have to go forward and stuff like that. Is it going to be an if? I don't see how an if's going to play into it. Is there going to be a loop? Yeah, because you're repeating the same kind of process over and over, right? You're going to be drawing and then you're going to turn. Then you're going to draw and then you're going to turn. Then you're going to draw and you're going to turn. And each time you draw, you go a little bit farther. So that's probably going to be a variable. Each time we turn, it's just going to be 90 degrees. So that's kind of a magical number. Maybe we'll define it as a constant. So we're going to want a loop. So our code is going to look something like this. Why don't we see if we can flowchart it out? And since I didn't have y'all draw the last flowchart, I want you to do this one with me. Alright, so the good old Terminator. Start. Now my declarations. I'm thinking 2 variables. One for the angle that it draws each time, and one for the length of the line. So let's do a declaration block that creates those 2 variables. And a right angle is 90 degrees, so I'm just going to say angle is equal to 90, or set angle is equal to 90. And the book always shows putting the word declarations in here, but that's not strictly necessary, but I'm going to do that. And remember, you can just use Control-Enter to add lines to a block. So set angle equal to 90, set length equal to, I don't know, let's start off with 10. So these are the two variables we're going to use, angle and length. Now we're also going to need some kind of loop, because we have to know how many lines we're going to draw. So I guess the number of lines that we're going to draw, we could also make part of our declaration. How many lines did I draw there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so set lines is equal to 14. And now we're going to loop. And the way our loop is going to control how many lines it's drawn is it's going to subtract 1 from the number of lines drawn. Or we could have a separate variable that we increased each time. That would involve one more declaration. I'm not sure which one is easier to understand, so I'm just going to do it the first way that I said. While the number of lines to draw is greater than 0, keep drawing. This is skipping that we needed to create the turtle. So I guess I'm going to put another block here. Just pull that one down. This is another process. Create a turtle named Alex. So while the line is greater than 0, we're going to make Alex go forward. Alex dot either FD or the whole word forward. I like FD because it's easier to type, right? And he's going to go length, number of pixels, and then he's going to turn. I showed him turning right each time. Alex.right, and he's going to go a certain number of degrees as an angle. And then we're going to increase the length, and we're going to decrease the number of lines because we've drawn a line, right? We started off with 14 to go, and then 13 to go, 12, 11, 10, 9. So we're going to have 2 more math blocks. One increasing the length, and one decreasing the number of lines left to draw. Doesn't matter in which order those happen. So length is equal to length plus 10. Let's just increase the length of the line by 10 each time. And then lines is equal to lines minus 1. And if I was doing total pure pseudocode flowcharting, I'd be putting the word set in front of all this stuff. Lines is equal to lines minus 1. And then go back to the while. And as I've mentioned 20 times, the book shows the while line going out on the outside. I like drawing the while line going on the inside. You can do either one. And then we're just going to make a process called wait main loop, which waits for the user to kill the program, and then a terminator underneath that. I think I'll put parentheses there. Okay, so that's our flowchart for our spiral program. As always, it's a struggle for me to get it all on one page for y'all to see on the projector. All right, there we go. Start at the beginning, stop at the end. Maybe increase the size of my font a little bit. You don't have to do all this stuff. I'm just trying to make it easier to read. On an exam, don't take the time to make it look pretty, because I'm not going to give you extra credit for it looking pretty, unfortunately. This needs to be correct. Okay, so there's my flowchart. Now I'm getting Nancy to draw it. So I'm going to go back to idle and create a new file, Mars7B. Name, date, spiral turtle program. If I could get this to scroll a little bit farther on that side, that'd be really nice. See if I can do that. All right. Okay, so start. Yeah, great. Pound sign start. We have some declarations. Pound sign declarations. Angle equals 90. Length of the line is equal to 10. The number of lines is equal to 14. I just picked that number because that's what I drew up there. Once we're done with this, we may think it'd be cool to, change it to 30 or 100 or something. Now we need to make our turtle. So import turtle. Alex is equal to turtle with a lowercase t dot turtle with an uppercase T, and then don't forget the parentheses in parentheses, because that's actually a module call, a function call. And we could set his speed and set his color and do fun stuff like that, but I'm going to keep it simple. Now we're at the while loop, because I've done the create turtle. While lines is greater than 0, colon, tab, Alex.forward. How long is he going to go forward? He's going to go the length of the line. So Alex.fd parentheses length into parentheses. Then he's going to turn right. Alex.right, and he's going to go our specified angle, which is 90. We need to increase the length because each time he draws a line, it needs to get a little bit larger. So length equals length plus 10, or length plus equals 10. They both work the same way, so I'm going to do it that way. Length plus equals space 10. And then we need to remove 1 from the line counter. Lines minus equals 1. Reduce lines by 1. I'm putting end while as though I were doing pseudocode, even though it's not strictly necessary in Python. That's why it's just a comment. And now we need to wait. I believe the command for waiting is just alex.mainLoop, parentheses in parentheses. And then we're done. So, hash sign stop. I wonder if this will work. Save as. mar7b.py. And it blew up because it called a main loop. That's not what the call is. I apologize. Let me go look up what the call really is. So I'm going to our online textbook, the How to Think Like a Computer Scientist. Well, it looks like it. Oh, I didn't create a window and then call main loop on the window. What happens if I just remove that line? Will the program work just as well? Let's find out. I'm going to delete that Alex main loop line and run it and see if it works just as well. Okay, yeah. So I don't know why that was necessary. I'm going to remove that from the flowchart, I guess. I'm going to go back to my flowchart, remove this wait main loop call because it turned out that it works just as well without it in the program. And so I'm going to make this no line just go all the way straight down to stop. Okay, so that's our flowchart, and that's our program that goes with it. While I'm wandering around, try changing a few things. Change the angle from 90 to something else, like 45 or 60. Change the number of lines. You see this place where it says 10? That's kind of a magic number. Change that. Make it 8 or 4 or 20. So these are the lines that I want you to try changing the values of. Change that one, just to mess with it. Change that one, and then change that one. The only one I'm not going to ask you to change is the number of lines because that is, an accurate representation. If it draws 4 lines, it's supposed to have gone down by 4. Couple of things I saw people do. One is if you make the length of it grow more slowly, like you just say line plus equals 1. Let's see what that does. And you don't have to do this because you've already made your program the way you want it to look. Very small. Okay, so it stopped real fast. What if I want it to be larger? Okay, I would increase the number of lines to draw. I want to draw 50 lines. All right, I'm feeling good about that. That's pretty cool. I wish it was drawing more quickly, so I could use the speed command to change it. Not going to bother, though. Another thing you could do is if you make a large enough angle, it'll draw kind of a spirograph shape. I mean, a star with a whole bunch of points. So I'm going to try 95 just to see what that does, or 85. Well, that's not what I was expecting at all. $160. And I'm goofing it up because I'm setting that as the line length and not the angle. I said I wanted to change the angle, and I keep changing the line length. So the angle I wanted to make like 92 or 95 or something. I'm going to give that a shot now. I made it 85. All right, not quite what I wanted. Kind of cool, though. If you ever went to Grandma's house and played with spirograph, you'd recognize shapes like that. How about if I make this angle also something like 160? So it's a really sharp curve. Now we're getting a star shape. If you wanted the line to always stay the same size, rather than increasing each time, you just comment out one of the lines of code. This one here that says line or length plus equals 1, we could comment it out. Maybe we should have made that a constant, right? That 1, it's kind of a magic number. We could have made that a constant, and we could have called it increase. and then you could set the amount that it increases each time. That would have been a cooler thing to do, so I think I'm going to revise my program to do that. I'm going to make a variable called increase, and I'm going to set it equal to more than 1. I'm going to set it equal to 10, like we had originally. And then instead of length plus equals 1, it's going to be length plus equals increase. And we're about done for today. All right, I think that's pretty slick. I like it. I stole these ideas from y'all when I was wondering about, so. A fun one was if it would, the angle was just like 92 rather than 90. Kind of like a Twilight Zone spiral. Something like that. Okay, let's make a Dropbox for this so that you can upload your code. You can also put your flowchart in there if you want. Remember how to download your flowcharts. You do a file save as, give it a name, and then you do a download as. So file save as, spiral, turtle, file download as a PDF. And I'm walking through that fast because I need to make the Dropbox for it so that y'all can get out of here. So this would be Dropbox J, folder J. Bless you. All right, if you refresh your Dropbox, you'll see Dropbox J. Just put your turtle code in your flowchart. A reminder that on homework 2, I said that if you gave me both a flowchart and pseudocode, you get extra credit. So, hey, good thing to do, just for extra practice. All right, guys, any questions? If not, I'll see you next week. If you have questions, we can hang out here for a while. It's our classroom until we leave.